Hello students, welcome to Study Doubt. This question is from Chemistry, chapter Thermodynamics. In the question, we have to calculate the enthalpy change for the process CH4 forms carbon in the gaseous state and 4 atom of chlorine in the gaseous state. This CCl4 is also in a gaseous state. And here, we have to also calculate the bond enthalpy of CCl in CCl4. Here, we have enthalpy of vaporization of CCl4 is given 30.5 kilojoule per mole. Enthalpy of formation of CCl4 is given minus 135.5 kilojoule per mole. Atomization of carbon enthalpy is given 715 kilojoule per mole. And enthalpy of atomization for the Cl2 is given as 242 kilojoule per mole. So based on these given information, we have to find the enthalpy of this reaction. So first write down all the reactions and then we will find the enthalpy change of this reaction. So here I noted down all the reactions. This is reaction 1. Here the CCl4 in the liquid state will change to the gaseous state, and this is the enthalpy of vaporization 30.5 kilojoule per mole. In the second reaction, carbon in the solid state react with 2 mole of chlorine in the gaseous state forms CCl4 in the liquid state. And this is the enthalpy of formation minus 135.5 kilojoule per mole. In the third one, this is the carbon in the solid state. It will convert to the carbon in the gaseous state, and the enthalpy of atomization is 715 kilojoule per mole. And this is the chlorine gas Cl2 will convert to 2 atom of chlorine in the gaseous state, and this is the enthalpy of atomization is 242 kilojoule per mole. And based on these all information, we have to find CCl4. It's in the gaseous state, to carbon, it's in the gaseous state, plus 4 atom of chlorine in the gaseous state. So how we will find it? So for this, you see here in the first reaction, we have CCl4 in the liquid state, and this is CCl4 in the gaseous state. And according to the question, we need CCl4 in the gaseous state. So this is required. But one thing that we need to also understand, this CCl4 in the gaseous state is in the product side, and we need this in the reactant side. Similarly, carbon we need in the gaseous state, and it should be in the product side. So as you see in the reaction 3, carbon is in the gaseous state, and now this 4 chlorine is also in the gaseous state. But here, if we see the reaction 4, we have only 2 chlorine present in the gaseous state. So to convert this 2 chlorine to the 4 chlorine, we need to multiply this with 2. So it can be written as 2Cl2 gaseous state forms 4Cl gaseous state, and this enthalpy of atomization will also be multiplied by 2 times. It's equal to 484 kilojoule. Now, let's consider this as reaction number 5. So let's add reaction number 3 and reaction number 5. So by adding reaction number 3 and reaction 5, so this is 3 plus 5, carbon in the solid state plus 2 chlorine in the gaseous state forms carbon in the gaseous state plus 4 chlorine in the gaseous state, and energy will also be added. So 484 will be added with the 715. So here total enthalpy will be 715 plus 484. It's equal to 1199 kilojoule per mole. Now we have to look into the first reaction. This first reaction, if we interchange it, so we can say that this product will be changed to the reactant side. Means we can write it as CCl4 in the gaseous state, and it will form CCl4 in the liquid state, and here enthalpy will be minus 30.5 kilojoule per mole. And now we can add with the reaction 3 and reaction 5 that we just did. So let's add this, and we can consider this as reaction number 6. So this 6 will be added with this reaction, we can consider it as 7. So we can write it as CCl4 in the gaseous state will be converted to CCl4 in the liquid state. And here change in the enthalpy is equal to minus 30.5 kilojoule per mole. Again we can add 6 and 7. It's equal to CCl4 gaseous state plus carbon solid state 2CCl2 gaseous state, and here we get C gaseous state and 4Cl again gaseous state plus CCl4 in the liquid state. So change in enthalpy will be equal to 1199 minus 30.5 kilojoule per mole. It's equal to 1168.5 kilojoule per mole. So let's consider this as reaction 8. Now, according to the question, we need only CCl4 in the gaseous state, carbon in the gaseous state, and 4-chlorine in the gaseous state. So these things we have to remove. So what we can do, if you see reaction number 2, we have carbon solid, 2Cl2 and CCl4. So we need to subtract 2nd with the equation 8. So if you subtract 2 from equation 8, carbon in the solid state plus 2Cl2 gaseous state, and this side we have CCl4 in the liquid state. So we need to subtract this. This carbon will be cancelled, chlorine will be cancelled, and CCl4 liquid will be cancelled. So remaining is CCl4 in the gaseous state form carbon in the gaseous state plus 4Cl in the gaseous state. And here the enthalpy of the equation, net enthalpy, is equal to 1168.5 minus 135.5 kilojoule per mole. So it's equal to 1304 kilojoule per mole. So this is the answer for the first part of the question. In the second part, we have to find the bond enthalpy. In the B part, we have to find the bond enthalpy of CCl in CCl4. So we already found the standard enthalpy of CCl4. So if we have to find the bond enthalpy, we have to divide it delta H by 4. So 1304 divided by 4, it's equal to 326 kilojoule per mole. Why we need to divide by 4? Because if we draw the structure of CCl4, it is formed by combination of 4 bond of carbon and chlorine. So if we have 4 bond of carbon and chlorine, and if we have to find the bond enthalpy of the one carbon and chlorine bond, we have to divide with the 4. So this is the answer of this question. If you have any doubt, you can mention it in the comment box. I will try to resolve it. Thank you so much.